in the CO2 to fuels problem, there's one central obstacle, and that is, how do you do that reaction selectively? So if you think about it, and you look at the thermodynamics, just literally what the thermodynamics tell you, what you'll find is that taking CO2 to CO, methane, ethanol, methanol, butanol, and a whole host of other products, ethylene, for example, all occur at a very, very similar thermodynamic potential. That means that just by using your electrode to discriminate whether and what composition of all those products I make, that is the core challenge. It's a selectivity problem. It's how do you direct CO2 to singly make one of those products. You don't want to have to purify it after the fact. If you could get a singular process that would take CO2 directly to, say, butanol, you'd have a truly game-changing technology. And we're not there yet. We're not even close to there yet. But we're thinking about what it is you can do to engineer that interfacial structure at an atomistic level to be able to take CO2 selectively down this multi-electron transfer pathway, rather than all the other competing reactions that could occur just as easily. The main thing you'd be able to have is, in principle, a room temperature, downscale, basically something that's portable that would be able to directly make fuel from a renewable energy source. I mean, if you think about it, right, if you have a solar farm out in Arizona and you happen to have a CO2 sequestering unit or something that an aquifer you can pull it out of, you would want something that is not a multi-million-dollar Fischer-Tropsch plant to be able to try to convert that to a fuel. So then you could do on-site conversion to a fuel. You could transport it. If you were to make, for example, methane, you could transport it in the same way we transport methane right now. There are a lot of opportunities that are afforded if you could selectively take CO2 and make a value-added product. But we're not there technologically yet, and that really involves a lot of basic science. But it's the fundamental problem. The reason we don't have these technologies now is we haven't cracked the selectivity problem.